Let's understand the difference between displacement and distance traveled using two different scenarios. First, let's look at a particle moving in a circular path. Here's our particle starting at point A. Watch as it moves along a circular path and returns to its starting point. Now, let's analyze the displacement. The displacement vector points from the initial position to the final position. Since our particle started and ended at the same point, the displacement is zero. However, the total distance traveled is the length of the path, which in this case is the circumference of the circle. Now, let's look at our second scenario, a particle moving in a straight line. Here's our particle at point B. Watch as it moves in a straight line to point C. In this case, the displacement vector points from point B to point C, and the total distance traveled is exactly the same as the magnitude of the displacement vector. This is because the particle took the shortest possible path between these 2 points. Let's compare these two scenarios. In circular motion, the displacement was zero even though the particle traveled a non-zero distance. In straight line motion, the displacement and distance were equal. This illustrates that displacement is a vector quantity that depends only on the initial and final positions, while distance is a scalar quantity that measures the total length of the path taken. Remember, displacement is always the shortest path between start and end points, while distance is the total length of the actual path taken.